In this video, I am going to be going over the difference between perimeter and area. Perimeter is a pre-existing knowledge base, but area is new, so I want to make sure we know the difference as well as how to find the area, and then just, of course, review perimeter a little bit. On this video, we are going to use this worksheet. It's not one of the ones we've done in class because I don't want to give away answers, of course. So let's talk first about perimeter. Perimeter is this outer edge of a shape, all right? The area is going to be everything inside of the perimeter. So it's the space it takes up versus how long it would take to walk around the outside, or what the distance around the outside is, to be more specific. So this is a parallelogram. The reason it's called that is it has two sets of parallel sides. Its left and its right side, you can see both slant just slightly, and then its top and its bottom are, of course, parallel as well. So on perimeter, we are concerned about what goes around the outside. So for right now, we're going to ignore this dotted line in the center. We'll get back to it in a second. What we need to do is we need to add all four sides up to get a perimeter. So in this case, we've got 9, and if they're parallel correctly, this one and this one both are 9 centimeters. All right, and then the bottom, which is base, this is also a base. A lot of times we'll say the top is base 1, the bottom is base 2. For this, we're just going to say they're both bases. It's not something we need so much in parallelograms. That comes up later with different types of figures. So now that we've labeled our whole figure to have the numbers in their correct places, what we are going to do is we are going to add them up to find perimeter. Perimeter is just taking all four sides and adding them. So it'll be 9 plus 9 for our two outsides. And then our top and our bottom would be plus 14 plus 14. And our quick math on this, is going to be 46 centimeters. And don't forget your unit of measure. It's very important that you have both pieces. And this is just by adding these up one after the other. Or you could do the 9 plus the 9, the 14 plus the 14. Whichever way is easiest for you, just always make sure when you line them up in your top to bottom that you have your decimal place value in the same place. So we still have to line them up. We don't want to put our 9 over here because our 9 is a ones place value. So we still have to use that invisible math of where our decimal is to line up all of our ones in the same place before we add together. Just a quick reminder, because I know decimals are still relatively new for some of my students. Now, area is different because we're not looking for the numbers that are provided out here. We want to know what's inside of here. And there's a formula for area of parallelograms. It is written, I'm going to do it over here out of the way, area equals base times height. Now, some of you may say, but Miss M, you've got, there's another thing. It's area equals length times width. And you're not wrong. Length and width can be another way to put it. It could also be called width times height. It depends on who you speak with. In this case, we're not using that because it's not a square. It doesn't have a length and a width so much. That's usually with depth. I want to keep it with the official base times height. And here's why. Let's talk about how we identify them. The base is usually the bottom. Now, in the rare occasion that a shape gets turned upside down, you might see a triangle with the base on top because that's the widest point. So base and width are going to be kind of the same thing. But we want to make sure we're using the right terminology. So this is our base. It is the bottom. So for here, we're going to say B equals 14 centimeters. All right. So then we have height. We know that height is the height that your doctor takes when you go and have your height measured, your weight measured, to see how you're growing. So normally you would think, oh, well, the 9, that's part of the shape. But is that standing up straight and tall, or is that kind of leaning a bit? when you take your height, you don't want to be leaning. So what we look for is our 90-degree angle to show that it's perpendicular, or that, as we said, we stand up straight and tall, not a little bit of a lean. There's not a wall we're leaning on. There's not a railing we're leaning on, or a desk. We want to be straight and tall. So this is actually going to be our height. Remember I said we'd get back to that 7 centimeters. The reason we have that dotted line is to make sure we know exactly what the height of the figure is. So in this case, it's going to be base here and height here. Now we've got our formula, so we want to find area. So let's fill in our formula with what we now know. We've identified it, let's fill it in. So we're going to have 14 times, and in this case I'm going to use a dot. We don't want to use x's. Remember, we're trying to get away from those, because as we get further into middle school math, we're going to have variables later. X's in the traditional times shape for an x as a time shape will start getting confusing. So use your dots, okay? And then 7. So it's 14 times 7 is the math that we're going to do. Now, I'm not going to write it out. I'm just going to give it to you for the sake of time. But 14 times 7 actually equals 98. Excuse me. 98. And we want to write our units in. It's going to be centimeters squared, or raised to the second power, because we're multiplying 2 centimeters by each other. So we need that exponent up there, and it's just called centimeters squared. Okay? And this is the difference between perimeter to area, and how we find both, just to make sure there's no confusion with those two items. I hope this helps, and I will continue to post about our other shapes. And please make sure, if you have any questions, you rewatch and figure out where you're having a little bit of trouble, okay?